Well, hi, and welcome to my shop here on July 29th. Just about the end of July already. Holy smokes. Today I'm going to be doing a careful assessment of the shortwave bands on this radio. I probably won't make any changes to the radio while I do this. And this is to get a notion of how the radio is behaving before I do the alignment, which I'll probably do tomorrow. And then I can redo this assessment and see what the difference really is. Now I have to warn you as a viewer, I often start into these kinds of experiments and they go haywire. For one reason or another, they totally fail. So that may end up being the case here. Now, last video, I was using my SDR radio. That's this little box here. Looks like a cigarette pack, small cigarette pack. But I didn't explain exactly how I was picking the signals up. I was picking up the local oscillator and picking up the front end resonance or response curve to the radio. So here's what I was using. Okay, this overly fancy looking thing, this is nothing more than a coil of wire. You could take and I do this regularly, take a clip lead and just wind it a few times and there's your coil. So it looks fancy, nothing fancy about this whatsoever. And what I do is, while looking at my SDR, I move it around the area of the radio I suspect where there's good signals that I might be interested in. In this case, I ended up just leaving it hanging kind of right in there. Something like that. That was picking up easily enough for the SDR to show, in particular the local oscillator. It's a very, very strong signal in most radios, easily picked up by another radio. Doesn't have to be an SDR. Any other radio held close enough to this is going to pick up the local oscillator. Okay, so here's what I'm doing today. At least this is what I think I'm doing. I've made a chart that basically matches the 5 bands on the front of the radio, the 5 different bands. So this actually represents the front of the radio glass. And I'm going to make 3 measurements per band. I'm going to do a measurement at the low, the middle, and the high. And we'll write down the frequencies. There I'm doing this in actual fact. I'll be using my signal generator over here. Like that, just as I put, well, okay, counter's acting up there, but it'll stop. See? What do you like? Presto, just like that. The power. So I will use the signal generator. I will calibrate it so I know what the output level is all the time. I can write it down here, or I will stabilize it. So it's, as I change frequency, the output of this thing changes. So I'll just make sure it's always the same output when I go to do it. And I will also indicate, this is my plan anyway, the frequency on the dial, where the pointer is on the radio, and the actual frequency that the signal generator is putting out. I'll make those 2 numbers down too. When I'm all done, we'll have some kind of impression of how well this is working. It won't do the broadcast band. This is all about the shortwave bands. Okay, wow, how's this going to go? I don't know, I think the best way to start this off, coffee. Okay, of course, right off the bat, things change. So I haven't done anything really yet, except I remembered to put the bottom plate on the radio. What an important move. I almost forgot to do that. That would have made the whole study bogus. So we don't want that to happen. So, and also, I said I was going to ignore the broadcast band. No, I'm going to start with the broadcast band, and that'll become the standard I'm comparing to, because the broadcast band, from all the use I've put onto it, seems to be just fine. So that's a good place to get kind of a baseline. That's the term I should be using here. I'm creating a baseline before making more changes to the radio. So there's 2 ways, there's 2 basic ways of doing this. One is you feed the radio a known signal, and then you measure and record the result. Another way is you feed a signal to the radio to create a known or expected output, and then you make a note of how much signal it took to get to that output. Now that's the more standard way of doing it. So now I'm not reading a voltage on the speaker. I'm still looking at the AVC voltage here, which I think is fine for my purposes. I have to decide what the target voltage is here. Now right now I'm on the 15 volt scale. You can hear what this sounds like. I have a 400 hertz tone. And what I'm going to do, just so I don't step in front of the camera, I'm going to move this. This right now is 1,000 microvolts according to the signal generator, which is calibrated. So 1000 microvolts on the broadcast band at 600 kilohertz gives you this much voltage. And that's what I want to record. Now let me just show you what happens if I go down by a factor of 10. Or another factor of 10. And go up. Now back to 1000. Here's 10,000. And here's a crazy 100.1 volts. My gosh, there'll never be a signal like that on the radio. So normal operation, I think, is coming in this area here, based on the kind of signal strength you would reasonably expect. So I'm going to pick the target to be right around 6 or 7. Let's pick 7. And I'm going to do this roughly. I'm going to do this by a factor of 10. You know, is it 1,000? Is it 10,000? Is it 100,000? I'm not going to sit there and nitpick over a little bit. So in this case, I would say, okay, we're between 6 and 7. We're in the target zone. Let me write this down because I know I'm going to forget it. 6 to 7 what? 6 to 7 volts of AVC. Somewhere in that range, and then we will. I'll adjust the signal strength of the generator to achieve that. Okay, let's try it. We'll try it right here. We'll go across to the next frequency. Since I've done the 600, the next frequency is roughly in the middle. Say we'll pick 900. Okay, so 900 dialed in. 900. I think we can get there from here. Can't quite see that. Oh, 900 right on. Okay, now we gotta look back. Don't look at the meter. Keep your eye on the meter. Max the meter. Okay, so we're in the target range of 6 to 7 volts, so I can record this. We're tuned to 900. The signal generator says 907. Not too far off. You know, that's kind of the width of the pointer here. So 900, I better write kilohertz here. These numbers are so similar. 907 is the frequency. I forgot, I didn't write it down. Okay, so here I would write down 10 times 1,000, 10,000. So that's the microvolt input that's required. That's a whopper of a strong signal, you know, 10,000. Like typical antenna signals, 50 microvolts, somewhere in that range. Maybe I'm doing this too high. I'm going to be able to even get this kind of voltage on the AVC. On the other hand, you know what? Let's just carry on. Let's just carry on. I can't anticipate what's going to happen. So we've done here. Let's go back to 600 and record the number 600. Okay, maxing it out. Okay, so it's in the range over here on the meter. Sure what to aim the camera at here. So now we take a look at the settings. It's exactly the same, 10,000. So 10,000 microvolts to achieve the 6 to 7 volts. Okay, very good. Now we'll go up to the other end of the band here. Try 1,500. How about 1,600? As it goes up to 17. So 16. Okay, I'll dial up 16 on the signal generator. Okay, there's a bit of noise there. You can see the peak quite fine there. Okay, so we're below the 6 to 7 measurement range. Okay, if I go up by a factor of 10, whoa, it's too much. Okay, things get a little complicated now. Okay, first check the calibration. Calibration's off. Okay, I've calibrated. We're in the 6 to 7 range now. So this is 100. It's 1,000. I made a mistake. This is not a 10,000, it's 1,000. That makes more sense. 1,000 microvolts. I've been writing this wrong. Read my meter wrong. Okay, good to make all the mistakes right at the start. 1,000 microvolts. Now we're up at 1,600. The actual value on here is 1,600. It's dead on. Number of microvolts is 100 times 10,000. Same thing again to get the same output, 1,000. Microvolts, kilohertz. Very good. Okay, so what this shows is the tuning is quite accurate against the dial. I'm going to say something about that in a moment. All the way across. It's perfectly on at the ends because of course that's where I did the tuning. It may be possible if you fiddled with that a lot more that you could find another combination of the two, the lower and the upper alignment adjustments, and just maybe pull the middle a little over because the middle is a little this way right now. So we dial 900, we get 907. No problem on a radio like this though. That's actually very good. And the same level, same signal sensitivity is the word I want, all the way across. So that's the broadcast band. 1,000 microvolts gives you 6 to 7 ABC volts. Oh my gosh. Okay, I'm going to do this with the rest of the bands and find out what happens. I think I know what I'm doing now. That's the most dangerous thing, when you think you know what you're doing. Oh, danger, danger. Anytime somebody says to you, I know what I'm doing, danger, danger. Okay, good. Okay, I'm not going to do this on camera though, because you can see how rangy it is. Okay, funny situation. I was just out on my deck, and the road I live on is very attractive for people to walk their dogs because there's almost no traffic on our little street. So often people are walking dogs by, and I'm looking at my cat and I'm thinking, what does the cat think is going on? The cat thinks people are patrolling our house with their dogs to keep our cats in line. I think that's why the cats spend a lot of time on our deck and don't go. The constant parade of big ugly dogs being marched past our house. Take a look at this cat. Okay, now, so the reason I have the camera on is because I'm working on the weak band, and it is proving to be very, very weak. And I just wanted to demonstrate the situation here. I'll turn this down just a little bit. So this is the 1,000. This is the same signal strength as was putting the meter up to this voltage level on the broadcast band, but on this band it's way down here. What does it take to get it up there? So I'm just going to turn it up and up. Okay, we got there. That signal, if you can read the control here, this is a times 10, times 100, times 1,000, times 10,000. It's 10 microvolts times 10,000. That's 100,000 microvolts. That's 0.1 volt on an antenna. I think that's possible, but only the very strongest of stations would do that. So there we are. So that's just demonstrating how this process is working, and maybe I'll pop in on the next band too, because the next band, the other shortwave bands appear to be sensitive. So we just immediately get a comparison here between all this, a quantitative comparison. That's what I'm after. Okay, so I have switched to the to one of the three band spread, this one here, and sure enough, to achieve this reading I only have to put in 150 microvolts. It's 150 microvolts on this band. It's 100,000 microvolts, the limit of a great antenna, really, on this band. The other thing too, it's quite apparent, is you never hear any noise here, but as soon as you flip to this band, excuse me, you can hear the atmospheric noise, so that indicates the sensitivity is in the range of the limit of the antenna. I mean, ultimately you want a radio like this, and all these radios, working well enough that they are limited by the antenna. And you know, it's actually easy to do. It's easy to have an antenna. That's the limiting factor in these radios operating. Okay, I'm going to carry on and maybe finish the whole thing before I record anymore. Okay, something really weird has happened. Just working away here, and then all of a sudden the radio just shut off. Really? It's gone. What happened? Now maybe it's just the plug in the outlet here. That's a little scary. It's all gone bye-bye. 112. I turn this down just a wee bit here. What to do? What could have happened? The wire may have come undone underneath the cabinet. No, I soldered that in place. It can't come undone. Oh my gosh, what has happened here? Just feeling the power transformer is pretty darn warm. What kind of power consumption? Is there any power consumption in here? Watts. It's drawing 23 watts. Why is it drawing 23 watts? Turn it off. Turn it off. 0. Oh my. Oh my. Oh no. Oh, and another oh. Oh, son of a gun. 23 watts. The only tube I can look at to see if the heater's going is the rectifier tube. The rectifier tube is this big glass one here. The rest of them I can't tell if the heaters were on or not. 23 watts of what? Maybe this tube failed just now. Or God help us, maybe this transformer just failed. And he can't help us with this problem either, because I know the deity does not stock radio parts. Uh-oh. Yeah, big uh-oh here. Oh no. Gotta let it cool off a bit, and then we're gonna take a look at that rectifier tube and pray it's just the rectifier tube failure. And what? Oh boy. Uh-oh. Bad. Okay, so let's hope it's this tube. That would actually be good news. 5Y4. So we're just going to double check. There's 2 tests to do a 5Y4. 5 volts on the heater. JX 0505000016. Set to English. We're good to go here. I think I saw the pilot light dip. I think I saw that happen. No heater voltage on this. No heater action in this tube. That's what it's. That's what it looks like right now. Oh no. It's very dirty on the top here, but the heater's actually on. That's disappointing. Shorts. Short light. Flashing doesn't really matter. The short in this tube is pretty exciting. So, rectifier. Oh my god, it's in the good. Okay, let's try the other half of this tube, just in case. We just switch one switch from 5 to 3. And we go just a little lower on this. And we do the same thing here. Let's check for shorts, just in case. P3, well, showing weak. How weak? So, let's fool with this English a little bit. Oh my gosh, what happened there? What's happening here? Oh my gosh. Is that, what is going on there? A little dirt in the control here. Okay, the proper setting, 16. The reason I'm doing this right now is I'm trying to find out just how much sensitivity there is in the result based on the setting of this control. Because just a little bit different sometimes. See, it's not. I don't know why it's jumping too good. This is not the cause of the problem though. Why did? Oh, I know why I didn't see it heating. You can't see it heating here because it's too dirty on the top. Tube's heating, but no high voltage. But this is the main guy for, creating the high voltage. No high voltage. Radio goes dead. Silence all around. Speaker problem? I don't know. Okay. Let me. I don't know what to do. Let me stop and think for a bit. I got myself a little excited here. Okay, so we're going to turn the radio back on. Now I have it feeding through the dim bulbs. So if there is a short in the radio, which I don't think there is, 23 watts is not a short. But if there is a short, we'll be saved by the lights. Right. And this is set for wattage. A radio like this, typically 50, 60, 70 watts. It's got a lot of tubes in it. Okay, I'm very hesitant, Okay, so we're going to turn it on here. Put the power to it here. Here we go. Now this may not even operate. If the voltage is too low, like 50, 60 volts, this device won't operate and it'll get stuck too. We'll see what happens here. Okay, so that's pretty normal. And the lights, 80 watts. Turn the volume up. Did I just spook myself out and nothing? Is that what happened? 87 watts. It's 87. Wait a minute. This might be on. This is on voltage. It's not on watts. 20, 30 watts. 30 watts. That's at low voltage. Raise the voltage. This could easily jump up. Tubes may not be conducting yet. That's roughly what it showed after I panicked. Now I can see the heater in the rectifier tube is on. And you can look under the dirt and see it. Oh my gosh, there's just nothing here. Oh my gosh. Some other kind of tube failure. It shouldn't cause the current draw to drop. I think the story is there's no B+. How can I find that out without taking the radio? I don't want to take the base off. Yeah, that's where this is going though, but I don't want to do it right away. I could pull one tube out and look for B+. Why don't we try that? We'll pull out any old tube, one that's not too hot. This one over here is nice and cold. We'll just pull it out and then stick a voltmeter down through the pins. We're looking for any voltage. Okay, I'm going to leave the dim bulbs on because I'm frightened. I'm scared. I'm a very scared guy. So we'll put this on 600 volts here. If we see 100 or something, we're doing good, I think. Put this here. Volts DC. Pull this out. Yes, you can pull a tube out of an operating radio. Now, I got to move the camera here because I'm going to fall over it. There you are. Okay. B+ of any sort. Hold one on the chassis. Down we go. Nothing there. Nothing there. Nothing there. Nothing at all there. There's just nothing in this radio. Oh, 42 volts there. Okay. Now 90 volts. You know what? That looks like B+, and this looks like the screen voltage. Greatly reduced. So if I just become a chicken now, I've got the radio running on low voltage, there's no sound coming out at all. Let's let's give it the works and see what happens here. Volume down. Oh, yeah, light's not on because in a situation like this, you need things to remind you the radio is switched on. Is there any sound coming out of that speaker at all? It's another thing I really should take a look at before I do something wrong. Is there any sound at all? I'm going to stick my ear right over here. Well, I'd say it's stone silent. You don't hear a darn thing. Let's turn the volume up then, my God. Stone silent. Stones are silent, by the way. Have you ever noticed? Oh my gosh. Well, I'll tell you, continuing on with the sensitivity study is not going to go well. I think the sensitivity has dropped. Here we go. This is watts. We're expecting 50, 60 watts. I'm going to put the power on full. This looks good. So this light here being bright indicates the output of the transformer is good. We're up at 60, 70 watts. Not a sound. Oh, I've got a tube out. Duh. Duh. Okay. Volume's down. Yeah, it's not going to work well with one tube out. Tube in. Watch the whole thing come to life, and then I'll just go drink coffee. That's what happens here. So at 70 watts, that's normal. Oh my gosh. What happened? Yeah, I'm on my second cup of coffee. Why did I get so spooked? Let's go on the broadcast band here for... Ooh. Broadcast band, take this off here. Oh. The level's gone. It should be scream and hiss. Well, I got sensitivity information here. I got everything set up to find out. Okay, let's go to 900. Did something happen here? 900. 900 on here now. I think we're approaching the end of my efforts today. 900. Can't get that. Okay, so before, this took 1,000 microvolts to get the 6 to 7 volts of AVC. Okay, let me calibrate. Yeah, way too much. So this is calibrating the output. I set it to 10 microvolts up here. 10 times 10. This is the 10 times 100, that's 1,000. This is the signal strength that drove the meter up. What's going to happen here? Okay, I got to tune the signal generator right on. It's gone. So something has happened? Oh, really? Yeah, you know what's happened? I disconnected the signal generator. Oh, for crying out loud. Okay, let me put it back on. Okay, we're back on. Okay, tuning. And we have no modulation. Modulation. Modulation very low. There's some funny things going on with my equipment over here, but I'm not going to worry about it. Everything's back to normal. We're all back to normal. Alright. So let me just get this right on the peak. So just below 6. Running full voltage. We're running a little low, 110. That's just a little low. Let's just bring it up a little Okay, 116. We're in the 6 to 7 range now. We are putting out definitely, I don't know. Yeah, definitely. So everything's calibrated, so this is a valid test. Is the radio operating the same as it was? So the way I remember it, that's exactly where the needle was. On this band before, we're at 906, and on the paper I wrote 907. I mean, that's just from tuning the radio. Okay, everything is just as it was. What the heck happened there? I don't know. I don't know what happened. Did anything actually happen? I don't know. Whew, okay, well, time is, oh my gosh, it's past 10:30 already, and I've got a huge driveway job to do today. You know, I think maybe I'm gonna finish this darn thing. I'm gonna finish this darn thing now. Darn thing. Okay, all done the study here. Now, my signal generator here. In order for this to show proper numbers, you see how it's jumping around? I have to have this control set like that. That turns on this output, but it decalibrates the standard output, the actual bench output down here. So what I've done is turn that off. Now turn up the radio. Calibrate this unit. Okay, so the pointer needs to be at the top. It is. So it's 10 times 1 down here. 10 microvolts now coming out of here, pretty sure. So what I'm doing now is a general sensitivity study. What I was doing before is somewhat uncalibrated comparison type thing going on, comparing this way and comparing this way. And I'll tell you the results in a moment. We're just finding out really how sensitive this is. Now, a really good radio will respond to 1 microvolt at the antenna, maybe even less, and really, really good radios. This guy, we are now at 10 microvolts coming out of here. Exactly what's on the antenna, I can't be sure. We're up at a fairly high frequency here. Stuff happens with these signals. But I can certainly hear it. Now, it's not maybe of the quality you don't want to listen to it, but that's 10. That's not bad. That's not bad for an old radio. Now, a real sensitivity measurement would be done with, a certain input level like that, causing a certain output on the speaker, a voltage reading of some sort. I'm not doing that kind of thing. Okay, so here's the results. So, generally speaking, in terms of accuracy, it's not bad. They all can be adjusted a little bit, of course. So, for instance, tune in 15.25, and in fact, you're listening to 15.94. So now that's a fair bit up here. Oh my gosh, that's a huge amount. 15.94. Tune in 15.1, here 15.14. 15.1, 15.14 is about here. Yeah, I must have made a mistake here when I wrote this. 15.35, 15.38. 15.35, 3.8 is up here. Yeah, this has to be a mistake on my part, what I wrote. Or it's way, no, it can't be the case. So I did something wrong there. So, and they're all kind of like that. Just a little bit out, easily adjusted and brought in. Nothing's wild. Now, the other thing is, what about the sensitivities? So if we start with the broadcast band, easily 1,000 microvolts gave us the 6 to 7 volts AVC voltage. To get the same reading, 500 microvolts less on this band, 100,000 microvolts on the C band. There's a problem there for sure. 1,000 microvolts on here, and by my kind of estimate, 5,000 on this upper band. It's also a little bit insensitive. Now, is that all normal? Geez, I don't know. There isn't a lot of difference between 11 megahertz and 15 megahertz. Why would this one be 5 times as sensitive as that? Alignment is a possible issue, which is why I've done this. So now we'll be able to align the radio and repeat this painful test. Is the radio still working? Yeah. Repeat this painful test and see what kind of improvements or changes come out of it. We're really looking for the reason why this band is no good. Now the thing is, if you're going to actually listen to shortwave with this radio, you're probably not going to use this band, because the key places where broadcast signals are around here to be received are around this band, 9 megahertz on this band, and on this one. Daytime, evening, then later at night, the bottom of this band here, but this upper part. So if this band is shot, just doesn't have the sensitivity, can't pick anything up, then you'd be limited to daytime or early evening frequencies here, 9, 11, 15. That's where it stands. And we are drawing all of 80 watts, which is totally normal. Magic eye is not in place, so there's a couple more watts there. Well, generally speaking, not bad. Not bad, really. I'm pretty sure I can make the spread bands work really well. This is the only guy that's got a question mark. Thank you very much for watching today, and I'm off to do some work on my driveway for the rest of today. See ya.